thousands of years, people have wondered, are we alone? If the answer is no, then we look forward to one of the most exciting events in the history of the human race.
The idea of extraterrestrial life really got rolling at the end of the 19th century when Percival Lowell started popularizing Schiaparelli's discovery of the so-called canals on Mars. These were seemingly an indication that there was intelligent life on the planet, and so a series of relatively imaginative ideas for communicating with those Martians were proposed, including one notion to light gigantic forest fires across the face of the Earth to spell out our message like some gigantic halftime card stunt, and presumably the message would be, "Help, fire." Well, people took the idea of life on Mars so much for granted that at the end of the 19th century, a wealthy Frenchwoman, Madame Clara Gauguet, offered a trunk full of money, a prize of 100,000 gold francs, to the person who first succeeded in establishing communication with beings on some other planet. With the one exception of Mars, she said, that would be too easy.
Whenever you're talking about extraterrestrial life or intelligence, since there's no unambiguous evidence that we've detected anybody or seen anything, the whole question is based on a lot of assumptions. And one of the assumptions, or the biggest assumption, is the so-called assumption of mediocrity, which says that since the circumstances of our existence here on Earth seem to be very ordinary, the Earth is a very ordinary planet, the sun seems to be an ordinary sun stuck in the middle of a quite inconspicuous galaxy, and so on and so forth, there doesn't seem to be anything special about us, and therefore we have to assume that there are other places which, by and large, are very much like the Earth in the universe, and that there are many of them, because we know that there are 100 billion stars in our galaxy alone, and there are at least that many galaxies in the universe, and therefore, why should we be the only ones?
So every time people have thought that there was something particularly special or unique about the Earth, so far it's turned out to be wrong, and therefore the optimists feel that if we argue that way in regard to life, that we're the only life in the galaxy of the universe, then that's anti-Copernican and therefore isn't a good way to look at things. So, you know, that's an argument. I don't personally find it very compelling, but it's not an unreasonable argument, and so the idea is that really one should go out and look for these technological civilizations.
Astronomers now speculate that as many as half the billions upon billions of stars in the universe have planets. But the mere existence of a planet does not necessitate the existence of life. Scientists believe that there's a range of distances from a star called the life zone in which life is more likely to form. This is the distance at which water is a liquid. Too close to the star, it would vaporize, and too far away, it would permanently freeze. While water is not essential to all forms of life, it's a nearly universal solvent which would help speed up the random chemical reactions believed necessary for the formation of life. 3 planets are technically within the life zone of our sun: Venus, the Earth, and Mars. Neither Venus nor Mars seems to have liquid water at the present time. But if the Earth were moved to either of their orbits, both the oceans and life would still survive on our planet. So other factors besides amount of solar radiation have hindered the formation of life on these nearby planets. Mars, 1/2 the size of the Earth and half again as far from the sun, presently has only a thin atmosphere. Its atmospheric pressure is too low to keep water in a liquid state. Water on the red planet remains as a vapor or as ice. Venus is nearly the same size as the Earth, but it's closer to the sun. Based on the amount of solar radiation it receives, temperatures on the planet should be about 150 degrees Fahrenheit. However, a runaway greenhouse effect caused by excessive carbon dioxide in the atmosphere keeps the planet's temperature at a hellish 900 degrees Fahrenheit. Earth's temperatures are certainly more moderate, although it had a similar origin to Venus. Soon after the Earth formed, volcanoes began to spew out gases from the interior. Much of the water vapor produced by the volcanoes condensed into clouds. Rain fell on the planet, creating the oceans. In 1924, the Russian biochemist Alessandro Oparin speculated that life could have originated from organic compounds in the primitive oceans. This theory was tested by Stanley Miller in 1953, when he conducted an experiment designed by Harold Urey at the University of Chicago. In a flask, Miller mixed methane, ammonia, water, and hydrogen, gases contained in the primordial atmosphere. This mixture was circulated past an electrical discharge, simulating lightning. When the products of the experiment were analyzed, an exciting discovery was made. They were found to contain 4 amino acids, structural units of proteins found in all living things. Miller's work showed that the gases of the primitive atmosphere, exposed to an energy source, could have combined to form simple organic or carbon-based compounds, similar to those found in living things. Astronomers and biochemists think that these same conditions exist or have existed on planets throughout the universe. If these elements have combined to create life on planets in other parts of our galaxy and the rest of the universe, what form might these beings have? Can we, in even our wildest flights of fantasy, ever come close to imagining what other life forms might look like? Forms of life on Earth alone are enormously varied and complex, and yet all these forms evolved from the same ancestors on the same planet. If all life except the simplest one-celled creatures were destroyed on Earth, and life was allowed to evolve all over again, it would probably not evolve into humanoids. There is such a variety of totally random paths that evolution could follow that it is very unlikely that it would follow the same path again. Life on another planet could have an entirely different chemical basis from life on Earth. But even if it had the same chemical basis, evolutionary and environmental factors could cause it to be substantially different from life on Earth. Perhaps it would be almost unrecognizable as living.
People often think in terms of spacemen visiting the Earth when they come here. They always look like human beings, one form or another. They have big heads, or they have green heads, or they have big eyes, but they always have 2 eyes, and they always have a nose below their eyes, and they have a mouth, and they have two legs, sometimes a tail, but they tend to be humanoid looking, you see, in science fiction. I think astrophysically there's no reason to believe that the humanoid morphology of advanced life is common. For example, if you triple or quadruple the gravity on the Earth, characteristic of a planet such as Jupiter, for example, which should be a common enough sort of planet, human beings of our form could not have evolved on a planet like that because the gravity is too large. We don't have the structural strength within the bones and the molecules in our body to support us, so that we'd most likely be a 4-legged or a 6-legged creature crawling around on its belly like an alligator, just because you're wasting too much energy standing up. Alternatively, if you formed on a light planet, it might be much easier to fly around. Even someone as massive as a human being could fly around quite easily on a low-gravity, thick-atmosphere planet. Furthermore, it may be that it's more advantageous biologically to evolve and grow in a liquid rather than in air. We don't know this. So it may be that when you look at all the life forms that there are in the universe, assuming that there are others, I think that 2 eyes, a nose, and a mouth is a very unlikely form, and a humanoid form is almost certainly unlikely.
Having made the assumption that other intelligent beings do exist in the universe, scientists would next like to estimate how many civilizations with communicative capabilities equal to or greater than our own exist. Dr. Frank Drake of Cornell University has created a formula for this estimation based on the average rate of star formation, the fraction of a galaxy's stars with planetary systems, the average number of planets in such a system with environments favorable for the origin of life, the number of planets on which life actually develops, the fraction of these inhabited planets in which an advanced technological civilization arises, and the average lifetime of a technical civilization. When all the calculations that can be reasonably determined by scientists are put into the formula reduces to one major unknown: the lifetime of a technical civilization. The number of extant technical civilizations possessing both the interest and the capability for interstellar communication depends on the average lifetime in years of a technical civilization. This number could be anything from millions within our galaxy alone to only one: us.
Shortly after Drake and his colleagues first explicitly wrote down this equation, they tried to put in their best estimates or guesses as to what these probabilities and lifetimes and whatnot are. And generally people like Drake and Carl Sagan and Phil Morrison are regarded as the optimists in the field, or have been for quite a while now. And they tend to choose values for these probabilities and lifetimes that many of us would regard as quite optimistically large, that is, because they seem to want there to be a lot of life in the galaxy. On the other hand, people such as my colleague Michael Hart and other people like myself aren't quite as pessimistic as Hart, but still believe the origin of life is quite an improbable event, would put a very small number in for this probability, a number not much bigger than 0. It's really just a guess as to how big this number is. And depending on whether you're Drake or Sagan or whether you're Michael Hart or something, you could come out with numbers that differ by factors of trillions in your estimate of what capital is. In other words, when Drake and Sagan finally go through their calculations and estimate capital N, they come out, typically, say 100,000 civilizations in our galaxy. And that means that if you've got 100 billion stars in the Milky Way, about 1 star in every million or so would have evolved a technological civilization on a planet around it. Whereas the pessimists, the extreme pessimists like Hart, would feel that the probability of, say, even the origin of life is so slight that you'd be lucky to find another technological civilization in the entire universe.
In 1976, Vikings 1 and 2 landed on Mars. They performed complex experiments to try and determine whether microorganisms similar to those found on Earth existed on the red planet. The results were ambiguous, leaving scientists to wonder whether unusual non-organic chemical reactions took place in the soil or whether there might actually be a very strange form of microscopic life on Mars. Scientists are anxious to send probes into the clouds of Jupiter and Saturn, which have warm internal temperatures and similar atmospheres to that on the primordial Earth. They also hope to orbit and perhaps land a spacecraft on Saturn's largest moon, Titan. This distant satellite is known to have water vapor and a substantial atmosphere. This atmosphere creates a greenhouse effect, possibly warming Titan to life zone temperatures. Already we've cast a message in a bottle into the cosmic seas. The 2 Pioneer spacecraft on mission to Jupiter and Saturn each carry a kind of postcard, a plaque depicting human beings and the Pioneer spacecraft's path and showing the location of Earth in the galaxy. These spacecraft, which will last for millions of years, will be the first human artifacts to escape the solar system. Traveling at a speed of 25,000 miles per hour, it will take these spacecraft about 25,000 years to travel the distance of 1 light year. The 2 Voyager spacecraft, also on their way to the outer planets and beyond the solar system, both carry records which contain pictures and sounds of Earth. Directions for decoding the cosmic records are written in the language of mathematics.
The search for life in space has already begun. We've traveled to the surface of Mars with the Viking spacecraft in search of signs of life. We haven't found any yet, but we're still looking and will continue to look at the other objects in our solar system, the other planets, which are fairly close by. Of course, the chances of our finding life in the solar system are fairly small. It's much more likely that we'll find life if it exists in space on other worlds, around other stars. But those stars are tens, hundreds, thousands, even tens of thousands of light years away from us. And even if we could travel at the speed of light, it would still take an incredibly long time to get to them. Well, actually, we can already travel at the speed of light, but not in person. We can go at the speed of light by communicating with radio astronomy and radio telescopes like these.
The National Radio Astronomy Observatory in Green Bank, West Virginia, has been used to search for extraterrestrial intelligent, or ETI, since 1960. The first such program, called Project Ozma, was named after the princess of the land of Oz, an imaginary place which is very far away, difficult to reach, and populated by exotic beings. Several other searches using radio telescopes have been conducted in the United States, Canada, and the Soviet Union. None of these extremely short-term projects has met with success, but they have provided a framework for more thorough current programs. One such current program is NASA's Project SETI, the search for extraterrestrial intelligence. SETI is divided into two complementary projects, one under the direction of the Ames Research Center in Menlo Park, California, and the other operated by the Jet Propulsion Laboratory in Pasadena, California. The Ames plan will concentrate on individual stars, whereas JPL's search will survey the entire sky. JPL's program will utilize state-of-the-art electronics and computer processing and small existing antennas, such as the 26-meter Goldstone antenna located in the Mojave Desert.
SETI is the new scientific word meaning the search for extraterrestrial intelligence, has ET right in the middle of it. And it's the search that scientists are engaged in all over the world as they try to discover whether or not there is intelligent life elsewhere. NASA has its own major SETI project, which when it is operational will be the most important in the world. What they're doing is they are building an extremely powerful computerized receiver that will scan over all reasonable radio signals, all possible parts of the spectrum that could travel throughout the galaxy, looking specifically for artificial signals from another civilization. The NASA project is much more advanced than any other SETI project that has ever been conducted. There have been about 3 dozen SETI projects conducted in the last 2 decades since the modern search for extraterrestrial intelligence began. Now, the NASA project is designed to use the most advanced technology available. Previously, the searches were mostly part-time operations using scrounged-up equipment and using the kind of technology that was only available to the average scientist, which was very primitive in those days. But now what NASA is doing is they're putting together a computerized receiver that will scan 8 million channels simultaneously instead of just looking at one channel or a handful of channels. In this way, by scanning this many channels and by looking at all possible parts in the sky, they hope that they could pick out from the noisy cosmic background an intelligent signal.
Even more sensitive and ambitious projects have been proposed for searching for ETIs. Project Cyclops would utilize an array of 1,500 radio antennas, each 100 meters in diameter. Another suggestion is to put a similar array on the far side of the moon, away from radio and television interference from the Earth. This arrangement, which would be hundreds of times more sensitive than any existing system, would be able to detect internal radio broadcasts of civilizations several hundred light years away. Unfortunately, the high cost of these projects makes it unlikely that they will be constructed in the near future.
I'm extremely optimistic about the chances of success of the NASA program because there are so many reasons to think that life exists elsewhere, and if it does exist, there's a good chance that some of it has evolved into intelligence. And if they're at least as smart as we are, they can probably broadcast radio signals across the galaxy. In fact, a remarkable thing is just using primitive human technology of the 20th century, we can already communicate across the entire width of the galaxy using just the existing Arecibo radio telescope and using existing transmitters. If we had an identical system on the other side of the galaxy, we could already communicate. Now, civilization that's, say, millions of years beyond ours could probably do much better than we.
Inadvertently, we have already broadcast our presence to the galaxy.
These characters here
For over 50 years, we've sent radio and television signals into space. Whether another civilization would care to respond to a life form which produced War of the Worlds, the Army McCarthy trials, and I Love Lucy remains to be seen.
Oh, come now, you can do better than that.
Walter Cronkite reporting.
However, another more powerful message has also been sent. On several occasions, beginning in 1974, the 305-meter antenna at Arecibo, Puerto Rico, has been used to transmit a message in binary code to the great cluster in Hercules, tens of thousands of light years away. The message can be converted into numbers and pictures which would tell another civilization the chemicals of which we're made, what we look like, and where we're located. The signal was strong enough so that a similar antenna, located 24,000 light years away, would be able to receive it. In 24,000 years, of course.
Suppose we did discover signals from an extraterrestrial civilization. I think that it would have quite an impact on people, because for the first time when they looked up, they would think, now where is it? Where are they? And they would realize, for the first time probably in many people's lives, they would take a look at where they stood in the galaxy, where they stood in the universe. Most people see the sun rise and set, and that's about it. They don't look at the solar system as a collection of planets which has come about and evolved, and that perhaps we're not alone.
It means that the differences between, say, Americans and Russians or Israelis and Arabs will look insignificant when we compare ourselves to some three-headed little green man on another planet. So that's the first impact. But more than that, because these creatures are at least as smart as we, there's a good chance they're a lot smarter, that they've existed for a lot longer. And so we may receive from them solutions to many of the problems that face us, such as how to handle resources, pollution, cures for diseases, even how to prevent wars.
And I think that it would give people a tremendously heightened awareness of the environment that they're in, not their earthbound environment, but their galactic environment. And I think that'd be a very good thing, whether or not we discover extraterrestrial civilizations or not. I wish people knew more about our galaxy. It's a neat place.
The most powerful scientific argument against the existence of extraterrestrial life is one that was first given by Enrico Fermi many, many years ago. He said, "Where are they?" What he meant was that if life exists elsewhere, and if it evolves into intelligent life, then they should be capable of traveling between the stars. So why aren't they here?
And then the question you have to ask yourself is that there are 100,000 civilizations, each one of which has been around for an average for millions of years. Why haven't any of them basically taken apart their solar systems, and or why haven't any of them come here in UFOs and whatnot? Now, some people, of course, believe in UFOs as representing visitations from extraterrestrial creatures, but most scientists, I think, don't feel that way. I mean, if you took a vote, that's not necessarily the best way to decide these things, but I think that you would get very strong balance in favor of their UFOs, whatever they are, not having anything to do with visits from bizarre creatures from other worlds.
Why isn't there some definite proof that we're being visited or have been visited in the past? This argument has been extended by a number of scientists, and, for example, one argument is that any advanced civilization could send robot explorers around the galaxy, in which case we might have found one if they existed. The fact that we haven't found such things makes us wonder, why haven't we found anything? So the pessimists say, well, this means that life probably doesn't exist elsewhere, or at least not intelligent life.
Given arguments like this, regarding capital N, there's quite a debate in the astronomical community as just how valuable it is to go out and search for radio waves or infrared radiation or something from some of these hypothetical civilizations.
But the single most important argument that has been conceived, to my mind, about why we should be doing SETI is this: if we don't do it, we'll never find it. We shouldn't be in a situation that the Arabs tell about, of an argument that was raging in a tent where a bunch of philosophers were discussing the number of teeth in a camel. Well, the Arabs were saying that a camel should have, let us say, 32 teeth for some philosophical reason. Another one said that they should be 24. And they each had a different abstract reason why the camel should have a particular number of teeth. It happened that a camel herder was listening to their conversation outside the tent, and he went away and discussed, and he looked at a camel, he counted the teeth, and he found that they were all wrong. Let's not be in the position of those philosophers who argue endlessly about whether life is likely, whether intelligent life is unlikely. These are interesting questions, they're worth doing, but let's not be obsessed with the arguments. Let's say we don't know. We simply don't know. There's some people who are smart who think that intelligent life does exist. There are other people who are similarly smart who think that it doesn't. Let's go out there and look for it. At the worst, we will find some astronomical information, which is itself worth having. At the best, we will answer the question beyond any doubt, and we will have our first connection with extraterrestrial intelligence.
Well, certainly it's simple enough to realize that we're gregarious people. We like company, and we'd like to chat with those other folks if they're out there. Their knowledge and their experiences may be just what we need to help us better understand what's going on in the universe. Actually, though, they're probably as puzzled as we are. But it's important to know that there are other beings, other civilizations on other worlds that have survived the hazards of technology. Our entire perspective on the universe will change if we do make contact. We can't afford not to look.
Albert Einstein's theory of the universe as a four-dimensional space-time continuum has completely revolutionized scientific thought. Our understanding of gravity began 400 years ago, in 1687, when Sir Isaac Newton presented his universal law of gravitation. This one law provided an explanation for observed phenomena such as the rising and falling of the tides, the motions of the moon and the planets, and the flattening of the Earth at the poles. Newton's theories were given more support when Edmund Halley accurately predicted the return of a great comet in 1758. Some 50 years later, Sir William Herschel found the first evidence that gravity was also at work outside the solar system when he observed one star revolving around another in a binary system. Then in 1846, the existence of the as yet unknown planet Neptune was predicted on the basis of its gravitational influence on the orbit of Uranus, and a final triumph for Newton's theory had been achieved.
Despite centuries of undisputed success with Newton's law of gravitation, cracks began to develop in the theory. Now, we still use it, of course, to send people to the moon and probes to the planets, but there are situations where Newton's law of gravity simply comes nowhere near close to predicting the actual behavior of nature. And so a better theory is needed. Well, now we have one, relativity. And to see how it came about, we have to look at some of the unusual results of experimental science of the last few centuries. The first